All right, so today we are going to appreciate blood volumes. And just to start with, um, these are the measurements within usually the ventricle. And since we've been looking at the left ventricle, we'll continue talking to the left ventricle. And so we will go step by step and just look at the types of volumes that we have. The first one that I'm going to talk about is one that is known as stroke volume. So what is stroke volume? So stroke volume is the amount of blood out, okay, out of the ventricle. Now, this is based on impulse. So this is the amount of blood out of the ventricle per impulse. And so if you have your SA node firing, okay, it fires this way, blood goes into the ventricle, the amount of blood that will come out is what is known as stroke volume. The second one is known as end diastolic volume. So the end diastolic volume, maybe if I should start by saying, usually at the end of filling stage, you find that blood is noted as end diastolic volume. So if you go through the phases that we had talked about earlier, you will find that after the sealing of the ventricle, what you're going to have is known as end diastolic volume. So let's have an example of 140 mils as having filled up the ventricle. We're going to call that end diastolic volume. And then we see that the ventricles start to contract, okay? So the ventricles will start to contract, and then we have our aortic valve open. And what happens when the aortic valve opens? We have blood being taken out. So out of this end diastolic volume, this is where you have blood taken out due to contraction. And why is there contraction? It's ultimately because of the impulse. Okay, so this brings us to C. The portion of blood that remains in the ventricle after contraction is known as end systolic volume, or the volume at the end of contraction. So this is what would have remained after stroke volume. So let's say it's 60 mils. So if you had 60 mils after contraction, how would you calculate for stroke volume? You'd say stroke volume is going to equal what was there minus what we have now. Okay, so if what was there was 140 and what we have now is 60, we are going to have 80 mils as our stroke volume. Awesome. Okay. Another term that I would like you to know is efficiency. So the ejection fraction usually states how efficient the heart is. It is a percentage of how much blood is ejected per contraction. So you usually calculate it as SV over EDV, and you multiply that by 100. So this is equal to the ejection fraction. So why bother about the ejection fraction? In the example that we have had so far, our stroke volume was 80. Our EDV was 140. And if you multiply that by 100, what are you going to have? You're going to have, if my calculations are okay, as we calculated earlier in class, this should be 57%. Alright? Now imagine that this is the stroke volume that you had was, let's say, 70 instead of 80. Then you're going to have exactly 50%. So which of these two hearts, heart A or heart B, is more efficient? Of course you would say heart A, because it is able to remove more blood against the same volume that it had. So it's probably able to contract more. So I gave this as homework earlier. What is the average EF of a normal physiological heart? Okay. The next one that I want to talk about, E, is cardiac output. So what is cardiac output? Cardiac output is simply the amount of blood that is ejected. So it's amount of blood ejected by the ventricle. This sounds very similar to stroke volume, but here's the catch. This one, instead of per impulse, this one is per minute. Alright, so how is it calculated? So of course you're going to say cardiac output is going to equal heart rate, which is the number of impulses per minute, and you multiply this by the stroke volume. Okay, so in this case, let's say we had a heart rate of 75 beats per minute and a stroke volume of 80 mils. You're going to say cardiac output is going to equal 75 beats per minute by 80. Alright, so this is going to give you 6,000. Okay, 6,000 mils per minute, or 6 liters per minute.